Okay, this is a video for Objective 38 in your money textbook. So if you don't have your money textbook, hit pause, go grab your money textbook. Our last video was on Objective 37, which was here. I still have the writing on it where we left off. That was on simple interest. Objective 38 is going to look at compound interest, which is something a little different. It's something that everyone eventually, as you start making money, should be taken advantage of when you start saving money. It's a way to actually make money in a faster way than what simple interest does. In the book, you can see Objective 37 was on page 71. And then I inserted some pages in here which would actually be for the extra credit workbook and tests. And so I rewrote the pages. I wrote page 71 and a fourth, because eventually we'll get to page 72. But like I said, Objective 38 is on compound interest, and it's going to be using a formula that you were just going to plug numbers in to get our answers. But what this objective here does is kind of explain compound interest. So you're not going to do these type of problems on a test unless you end up doing the extra credit later on. But this explains what compound interest is. So simple interest takes whatever your amount you're investing or borrowing and just uses that amount for the given time period. What compound interest does is it takes the money you've earned and reinvests it. So each time they figure out the new earnings, you're going to be investing more money. An example in problem number 7 here is you're investing $400 at 7% compounded annually, meaning they're going to re-establish your principal every year. Compound annually means per year. So instead of just doing like in Objective 37, we would take 400 times 7%, which is 0.07, and we would times it by 5. And let me type that in the calculator here just to give you an example of what that would equal. So 400 times 0.07 times 5, you would earn $140. Okay, would be how much you would earn, which would give you in turn $540, because you'd take your original $400 of principal plus 140, you'd end up with 540. But what compound interest does is takes whatever you start with, and if it's compounded annually, means after that first year, they're going to do the P times R times T. So 400 times 0.07 times 1 would give you $28. So now you add that to the original. Now the second year, instead of starting with 400, you're starting with 428. And then they do it again. They take 428 times 0.07 times 1 gives you this amount, $29.96, so almost $30. Add that to the 428 you started with. Now you have, again, instead of using 400 for your third year again, you're going to use 457.96. And then they keep doing that every year. Okay, and then you can see by the 5th year, the total amount, because we start with a new number each year, is 561.02. Whereas if we just use simple interest, it would have been 540. So it doesn't look like a ton in this example with it's just $21 more, but that's with $400 starting off with. So if you were going to use $4,000, now you'd be looking at a difference of $200 in your investments or savings. And then over time, that's just going to grow higher and faster the more years it goes on and the higher the number gets. So again, you're not going to be doing that problem, so you're going to turn the page a few, and we're going to get to page 72 here, which is objective 38, and they're going to be giving you a formula. It's going to be the same, basically the same formula or variation of the same formula for each problem, and you just have to plug numbers in and then get the answer. Okay, so we'll look through these 6 problems. 4 of the 6 problems are very straightforward, and you just plug the numbers in and get an answer. 2 of them you got to do one extra step to solve, and actually number 7 is one of those type. So I will go through and let's talk about these and learn how to use this formula. So number 7, opened a savings account 9 years ago. And they had an interest rate of 4%, compounded annually. Today, she had an account balance of $426.99. So that's not how much she earned, that's what the balance is at. Okay, it says if Sienna never deposited any more money into the account, how much did she deposit in the account originally? So how much did she deposit originally? That is what is called our principal. So that is what we're going to be looking for. Now here is the equation for finding a balance when you invest or borrow with something compounded annually. Okay, so B is the final balance. Okay, now this first step right here is where I'm plugging in the numbers into this formula. So B is the final balance. It says in the problem her final balance is $426.99. P is the principal. That's what we don't know. Okay, it says that's what we're asking for. How much did she deposit in the account originally? So I leave the P there. 1 is part of the equation or the formula, so that stays there. R is the interest rate as a decimal, so I change 4% to 0.04. And then the N, which is the exponent here, is the number of years. So it said 9 years ago, so I put the 9 in there. Okay, now when we have numbers on both sides, what we need to do is, there's nothing we can do on the left side right now. The 426.99 is going to stay there. We need to do these steps here and then look at solving. So the first thing we're going to do, order operations, we're going to add up the parentheses. Okay, so we take 1 plus 1.04, so that's where I get this number. Okay, now the next step, we have to take care of this exponent. Now with the calculators we have at school, it's pretty easy to show you how to do that. I will make a separate video of how to do this on a phone calculator. But basically what you're going to see somewhere on your calculators is a button that looks like this. Okay, that would be on your calculator. Okay, so if I wanted to do this right here, I would I'd type in 1.04, then I would hit my button that looks like this, and then I would hit what my exponent is. Okay, and that right here would give me this answer. Okay, and I rounded a little bit. I carried out 4 spots. But that's, and I'll do a separate video for that. But that is how you do an exponent in the calculators. Now, once we get this equation, now we've done a little bit of this in objective 37. To solve for this, we undo what's being done to this letter. P is being multiplied by 1.4233. So I'm going to divide each side by 1.4233. Now I didn't even write these out. Pretty sure I typed this in. Type 3's out like that. So these cancel out. I'm left with just the P, and then I get the 426.99 divided by 1.4233, and it comes out to be 300, meaning they started out with an investment of $300. Okay. Now, that will be the harder type of problem that you'll see in this objective, and there's one more of these in a little bit that we'll look at. The next ones are just going to be straightforward, putting numbers into a formula. So let's look at number 8. It says they deposit $2,500 in a savings account that earns 3% per year, compounded monthly. You're going to see how that changes in the formula, and you're not going to need to know why the formula changes or when to change it. It's going to give you the formula. They leave the money in the account for 5 years, and they do not make any more deposits, so they just let this money grow. It says, what is the final balance? Okay, so here's the formula. It says in the formula, B is the final balance. That's what we're looking for. So again, number 8 here, I'm leaving B as a B. There's no number to go in there right now. P is the principal, how much money they put in. That was $2,500, so that goes here. The 1 is part of the formula, it goes there. R is the interest rate, so that goes here. Okay. The 12, now you don't need to know why this comes in here, but it comes from being compounded monthly. So they take normally what you would have as a year and divide it by 12. Okay. But again, that's part of this formula, so you don't have to figure out why it's there. They give you the formula. Now, make sure you read this part, because this is different than we've done in the past. It says N is the total number of months. So this is the one extra step you have to do in this problem. The time is 5 years. They want N in months because they're doing this every month. So they need to know how many times you have to do this, okay, because it's compounded monthly. So 5 years times 12 months a year, 60 months, that's where the 60 comes from. Okay, so now it's just figuring out all the numbers on the right side, because we want the capital B on the left side. Again, if we're in school, the calculators we have there, if you have a nice calculator, if you type this in correctly, you can type it all in at once and get your answer. If you're using a phone calculator, we have to use order operations. So the first thing I do is I look in the parentheses, and then there's division in there. So I need to divide 0.03 times 12, and I get this 0.0025. Now I'm still inside the parentheses because that's order operations. I add those two. It's easy adding. You don't need a calculator. 1 plus 0.0025 is 1.0025. Okay. Now this is the key spot. You have to do the order operations correctly. You can't multiply 2,500 times this 1.0025. You have to do this exponent. So again, you would be in that spot, you would be doing 1.0025. Whatever calculator you're using, you got to find this button. Again, I'll make another video for that. And then you would hit 60. Okay. And it doesn't change the number a bunch. You'd think it would, but that number is just barely over 1, so you're multiplying a number just barely over 1 a whole bunch of times, and it doesn't get much bigger. So when you type this in, that gives you this number here. Okay. Now you can just leave that number in your calculator because it's probably going to be some long decimal. Just leave it in there and then hit times 2,500. Multiplication doesn't matter what order you do it in, so just leave that number in, hit times 2,500. This is what you're going to get. You round that to the nearest cent, and there's your answer. Okay. Number 9 is basically the same problem. There's little differences here, so you got to be careful. Okay. Number 9. Certificate of deposit, it's like a savings account. Put in $19,000. Okay, that's what purchases a CD, not the CD that you listen to, but a certificate of deposit. If you purchase one of those, that's the investment price, $19,000. Interest rate is 8.5, compounded quarterly. Okay, quarterly, maybe you don't know this, means 4 times a year. If you're doing something quarterly, you're doing it 4 times a year. And here it says, what is the final balance after 5 years? Okay, so again, we are looking for the final balance. So B stands for the final balance, so that is staying there. P is the principal. $19,000 was the principal, so that goes in for P. 1 is the part of the formula, so that just stays there. R is your interest rate, so you change that to a decimal. Remember, it's 8.5, so you move it twice. 1, 2, and you put a 0 in the open spot, so that's 0.085. Again, 4 is part of the formula, and the reason it's 4 is because it's compounded quarterly, so we're doing it 4 times a year. Okay, so that stays there. Now again, here's the thing, we're used to being N being the number of years, but since this is compounded quarterly, N is representing the total number of quarters. Okay, so if it's 5 years and there's 4 quarters in a year, okay, because we're doing it 4 times a year, 5 times 4 is 20 quarters, so that's where this 20 comes from. Okay, now we do the exact same thing we just did above. We have to do order operations, so we take 0.085 divided by 4. That gives us this 0.02125. We have to add 1. That's where we get this. Easy addition. This is where a mistake can be made. Don't multiply these two. You have to do the exponent first. So you're going to type in the 0.012125, that XY button, to the 20. That's going to give you, so this right here, you type that in your calculator, will give you this number. Okay, now just leave that number in your calculator, hit times 19,000. You're going to get this number, and when you round it, here's your answer. Your beginning investment of 19,000 after 5 years would now be worth 28, almost 29,000. So by doing nothing in 5 years, this person would have earned almost $10,000. Okay, so that's the power of compound interest. Okay, 2 more problems left. No, 3 more problems left. Okay, 2 of them are pretty straightforward. Number 10 here is like number 7. So we're looking for the principal. Okay, so again, this one can be a little confusing. You opened an account 2 years ago. So some of the key numbers here, 2 years ago, 7% compounded annually. Okay, they don't put any more money in or doesn't take any out. And now today the balance is $1,831.84. How much did he deposit originally? That means the original deposit is the principal. So we are looking for the principal. So now we're going to take this formula and just put in what we know. The new balance, B, is $1,831.84. We don't know the principal, so that stays P. 1 is part of the formula, goes there. Interest rate, 7%. We move that over twice, is 0.07. And then N, now in this problem, since we're compounding annually, N goes back to the number of years. And this was just 2 years, so 2 goes there. Okay. So again, to solve this for P, you do the order operations here until you just get a number times P. So we have to add 1 plus 1.07. It's there. Now we have to do 1.07 to the second power. So you'd hit 1.07, hit that XY key, and then 2. That gives you is 1.1449. And again, as you're doing this, if you're not understanding a step, actually type it in while I'm talking about it and get used to these steps. So now we have this number times P. So to undo that, this is the one-step algebra problem. You do the opposite of multiplication. So if I want to get rid of this, I'm going to divide each side by that number. These will cancel out. So this side I'm left with just the P. Over here I type in 1,831.84 divide by 1.1449, and I would get 1,600. Okay. So again, that's the solving one. It's kind of one extra step. Sometimes people get a little confused on that, but take your time. The last two are just straightforward using the formula. Okay, I'll read through them a little quicker since we did a couple slower up top. He's going to deposit 2,900, so that's a key number. It has an interest rate of 3%, key number, and it's semi-annually. Semi-annually means twice a year. Okay, he doesn't put any more money in or take any out, and it wants to know what's the final balance. Okay, so here's the formula. Just put in the numbers. Final balance, that's what we're looking for, so I don't put a number in. P is the principal, 2,900, right there. 1 is part of the formula. Okay, R is your interest rate. It's 3%. Move the decimal to the left twice. It's 0.03. 2 is part of the formula, and again it's a 2 because it's semi-annually. Okay, and then N, again, a lot of times means years, but here, because it's compounded semi-annually, you are going to figure out how many semi-annual periods you are compounding this value. So it says they want to know this after 11 years, and if we do it twice a year, that means we're going to have this done 22 times. So that's where the exponent comes from. Order operations. You have to take the 0.03 divided by 2, so that's 0.015. Just leave that in your calculator, hit +1, because you got to add next. You get this. Again, I won't write this out every time, but now at this point, don't multiply these. We have to do the exponent first. So again, you're going to do 1.015, find this button, the XY button in your calculator, and hit 22. It's not going to change the number a bunch, but it makes it a little bit bigger. That equals 1.387, so on. Leave that number in your calculator, hit times 2,900, you get this, rounded to the penny. Here's your answer. Okay. Now you could definitely stop the video now or fast forward to the end, but I'll do one more problem here. It's the same type of problem. Okay, just some different numbers. They're going to put $850 into a saving account. It only gets 1% interest, but it's compounded daily. Okay, going to leave it in there for 5 years. Assume there are 365 days in a year, so we're not, I know there's a leap year in there, but we're not going to deal with that. It says, what is the final balance of the account? So again, we're looking for the final balance, which is B. So we have that in there. P is the principal, $850, which it says right up here. 1 is part of the formula, so you leave that there. R is the interest rate, 0.01 because it's 1%. 365 is part of the formula. Okay, the reason it is that is because they're compounding it daily. Okay, and then the N is the number of days that this takes place because they're doing it daily. So don't just write 365. This is happening for 5 years, so you take 365 times 5. Your exponent is 1,825. Okay, so again, up here I got right to the answer because I did it using one of the school calculators, you can type it in all at once. But again, if you're using like a basic calculator or phone calculator, here's your setup, just like above. You have to do this division first. It gets you a really small decimal. In your calculator, just leave that there, hit +1. Now you have this number, and we need to do the exponent first before we multiply, because order operations, you do exponent first. So you'd have this number in your calculator, you're going to hit that XY button, and then 1,825. And now you would get this 1.05 number, and then times your principal of 850, get this rounded and keep it at 58 cents. Here's your answer, which right here, letter A. So you got to be careful, because a lot of times with multiple choice, even if you're close, you'll see the right answer. But if you look at A and D, they're very close. Okay, so so that's probably one of the longest, but I wouldn't say the hardest objectives. It can be tricky, but all it is using a formula for the most part. Okay, so that'll be the end for the test of 3738. We'll look at objective 39 in the future, which has more of these type of problems, very similar. Okay, we'll take a look at that next. Again, if you get to your workbook, not sure what page you'd be on. Let's see. You want to find, so here's the beginning of practice 3738. 37 goes much faster. Check your answers, and then again, start doing some of these. Make sure you do a couple that ask for final balance. Okay, ask for final balance, and make sure you do at least one or two that ask how much did they deposit, because then you're looking for that P, or the principal. Okay, do a couple of those, check your answers. When you feel ready, ask for the test. Okay, and then I will send you the test, and then your next test would be 3940, which is a requirement for Yale, but it's an extra credit for MIT. Also look for the video that I will put out right after this about how to use your phone calculator to do the exponents. Okay, if you have any questions, let me know.